Hello guys, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to start another chapter in the top 15 question series, that is JEE 2023. The chapter is the limits, and it is under the portion of calculus. This is the first question, and before going to discuss the total 15 questions, I want to say something. Thank you so much guys for believing in me and subscribing this channel. And also, if you have any doubts, please comment in the below. I will answer to that question also. And if you have any personal doubts regarding about JEE Mains preparation, you can message me or you can find me in the Telegram group. And if anyone didn't join the Telegram group, join the Telegram group also. The link is given in the description. And now let's discuss the questions one by one. So basically, this is the first question, that is limit extending to pi by 4. 8 root 2 minus cos x plus sin x whole power 7 divided by root 2 minus root 2 sin 2x is equal to, and here are the options, that is 14 root 2, 7 root 2. So basically this type of questions, how to solve? First we have to check step 1. Step 1, we have to find which indeterminate form is. So basically, when we keep the limit extending to pi by 4 here, you will carefully see 8 root 2 minus, when we substitute pi by 4, it is 1 by root 2, 1 by root 2. It is 2 by root 2 and it is root 2 whole power 7, which is 8 by root 2. And again, when we substitute pi by 4 here, it will become sin pi by 2, and sin pi by 2 is 1, and root 2 minus root 2 is 0. 0 by 0 form. So basically, it belongs to the form of 0 by 0. So I already said in the series of one shot, that is for JEE Mains 2023, in the limits chapter, I already discussed that when the limit is 0 by 0, we have three options to solve the question. That is, first rationalize, second option is L'Hopital rule, third option is factorization. Here factorization is not possible and rationalization is possible, but it is not advisable, and the next one is L'Hopital rule. So here we are going to directly apply the L'Hopital rule, which says that you have to differentiate the numerator and denominator separately. So when we differentiate the numerator, you will get here 8 root 2 differentiation is 0. So it will become 0, and here it will become minus 7 into cos x plus sin x whole power. Here it is 6. And next, the cos x plus sin x. What is the differentiation of cos x plus sin x? It is minus sin x plus cos x divided by, here it is root 2 minus root 2, here it is 0, it is minus root 2 cos 2x, sin 2x it is cos 2x, and 2x it is 2. So here it is minus 2 root 2. So after applying the L'Hopital rule, we are getting minus 7 cos x plus sin x whole power 6 minus sin x plus cos x divided by minus 2 root 2 cos 2x. So now we have to check whether this term is getting 0 or not. Definitely this term is getting 0, and definitely this term is getting 0. So this term we can directly substitute the value here. So what will the value here? When we substitute pi by 4, it is 1 by root 2 plus 1 by root 2, that is root 2. Root 2 power 6, it is 8. 8 7 the 56, that is minus 56 into minus sin x plus cos x divided by minus 2 root 2 cos 2x. And now it will become minus will get cancelled. And when we check here, minus sin x plus cos x, again when we substitute pi by 4 limit, it is getting 0 by 0 form. So again we have a chance to rationalize, that is applying the L'Hopital rule for numerator and denominator, and you will get 56 into, what is the differentiation of minus sin x? It is minus cos x. And what is the differentiation of cos x? It is minus sin x divided by, here it is 2 root 2 cos 2x, it is minus sin 2x. Minus sin 2x, and for 2x it is 2. So it will become 4 root 2. And here when we take common minus, you will get minus 56 into sin x plus cos x. Sin x plus cos x divided by minus 4 root 2 into sin 2x. Here sin x plus cos x, what is the value of sin x plus cos x? Here it is directly minus will get cancelled, and when we apply pi by 4 here, it will become 1. So you can remove this, and here it is sin x plus cos x. What is the value of sin x plus cos x here? The value of sin x plus cos x is 1 by root 2 plus 1 by root 2, it is 2 by root 2, it is root 2 only. That is 56 into root 2 divided by 4 root 2. Root 2 will get cancelled. 4 ones, 4. 4 ones are 4, 4 16s. 1 second. 8 7 are 56. Is it here correct? It is 4 root 2 only. Not here, it is mistake here. 4 14s. 14 4 56 now. So the answer is completely here 14. So the answer is 14. That is A option. So like this you have to solve it. First you have to, step 1, in the limits any question for JEE Mains and advanced, you have to check what is the independent form present in it. In this question it is 0 by 0. So for solving 0 by 0, what are the methods available? You have to check with that once. So the methods are available are rationalizing, factorization and L'Hopital rule. Here the question is solved by L'Hopital rule. Now second question. They are saying that let beta equal to limit extending to 0 alpha x minus e power 3x minus 1 divided by alpha x into e power 3x minus 1. And the options are, for some alpha belong to R, then alpha plus beta they are asking, and the options are 14 by 5, A option, B option is 3 by 2, C option 5 by 2, D option is 7 by 2. So basically this is the second question. What they are asking, basically these are all the questions in the previous year. We can definitely say these questions are from January attempt. This question came in the January 2023. So doing this type of questions is really beneficial for you for the April attempt because the pattern repeats. So you have to do this type of questions only. That is the reason why I bring the top 15 question series. And now discuss this question. Let beta equal to limit extending to 0 alpha x minus e power 3x minus 1 divided by alpha x into e power 3x minus 1. So you already know by observing these things, these two things, it is clear that there is an identity here. E power x minus 1 divided by x equal to 1 when limit is approaching to 0. You already know this identity. Directly you can apply here. But it is very good if you identify that for the numerator part you cannot apply because it is in the minus. When it is in the multiplication you can apply. So I am solving this question, that is beta equal to limit extending to 0 alpha x minus e power 3x minus 1. So basically we can multiply minus. What we will get? Plus 1 minus e power 3x. And in the down it will become e power 3x minus 1. What is in the box? It is 3x. So we need 3x and we can multiply 3x. So when we observe these things here, it is clear that when limit is approaching to 0, this thing will become 1. So what we can write? We can write beta equal to limit extending to 0 alpha x plus 1 minus e power 3x divided by, it is 3 alpha x square. Why? Because this thing is 1 alpha into 3x into x. What will become? 3 alpha x square. Now we have to find again. We have to substitute once again. Suppose if I substitute x equal to 0 here, I can check again. When x is 0, it is 1, 1 minus 1 0. That is 0 here numerator and denominator it is 0. It is 0 by 0 form. Now you have to think 0 by 0 form, how we can solve that. It is solving by L'Hopital rule. So I will get beta equal to limit extending to 0. It is alpha minus 3 into e power 3x divided by 6 alpha x. Now we have to check. Again we have to substitute limit. So for every substitution of limit, the limit should exist. So when I substitute alpha equal to 0 here, what will be the numerator part? It is alpha minus 3 into e power 3x. It is, when we substitute 0 here, e power 3x becomes 1 divided by, when we substitute 0 it is 0. But the numerator is not 0. So we can directly imply that alpha minus 3 should be 0 and alpha equal to 3. We got alpha. Now we got alpha. We can directly substitute here alpha and we can evaluate beta. Beta equal to here 3 minus 3 into e power 3x divided by 6 alpha. Alpha we already got, that is 18x. And now and again we can apply again 0, that is extending to 0. What we will get, that is L'Hopital rule. Again applying. Again L'Hopital rule. What you will get? The differentiation of 3 is 0, that is 0 minus 3 is 9 into e power 3x divided by it is 18. When I substitute again 0 here, this thing will become 1 and it is equated to beta. So what will become? 9 ones, 9 twos. So beta equal to minus 1 by 2. Beta equal to minus 1 by 2. Now we have to check. Here beta equal to minus 1 by 2, alpha equal to 3. They are asking alpha plus beta. Alpha equal to 3, beta equal to minus 1 by 2. It will become 5 by 2. Option C is correct. Yes, it is correct. So like this you have to solve. It is very clear that here you have to apply this identity. Without applying this identity also you can solve, but it will become lengthy. You have to find the way in which you can solve the question very simply and save the time. It is the second question. Now third question. They are saying that if limit n tending to infinity root of n square minus n minus 1 plus n alpha plus beta equal to 0, then 8 into alpha plus beta they are asking is equal to what? Option A 4, option B minus 8, option C minus 4, option D plus 8. So basically this is a question. The third question. Now it is the time for n tending to limit, that is n tending to infinity limit. Up to now you solved 0 by 0 forms. Now it is the time for infinity form. When you substitute infinity here, it will become infinity, that is complete infinity. So it is indeterminate form only. So for this I already said in the limit series, that is change makers batch one shot series for JEE 2023, what I will say in that chapter, when the limit is given n tending to infinity, you can directly say, that is you can directly substitute n equal to 1 by t and you can directly change this limit into limit t tending to 0 and substituting n tending to n equal to 1 by t, you will get 1 by t square minus 1 by t minus 1 plus alpha by t plus beta equal to 0. And when t equal to 0, we have to solve this thing and we can get answer. Limit t tending to 0, what it will become? Root of 1 minus t square divided by t square plus alpha by t plus beta equal to 0. What I can do now? I can take LCM, that is limit t tending to 0. The LCM here is t. So because it is a t square, under root it will get cancelled and it will become t. And again here same 1 minus t square plus alpha plus beta t equal to 0. They are given that this limit is equal to 0. Now we have to substitute t equal to 0 and check whether it is true or not, that is limit is existing or not. When t is tending to 0, the numerator portion will become 1 plus alpha divided by 0. So basically the limit, what we can say here is 1 plus alpha must be equal to 0 because the limit should exist when we substitute t equal to 0. Alpha equal to minus 1, it is clear here. Alpha equal to minus 1. So basically we can directly write here alpha equal to minus 1. Alpha equal to minus 1. Now you can directly evaluate this limit, that is it is now 0 by 0 form and you can apply the L'Hopital rule. Applying L'Hopital rule. What you will get? Limit t tending to 0, root x, that is root of something. What it will differentiation? 1 by 2 root 1 minus t square into 1 by 2 root x. What is the differentiation of x? That is 1 minus t square. Differentiation is minus 1 minus 2t. It is over and the constant is 0 and here it is plus beta divided by here 1. Now when we substitute t, this thing is equal to 0 now. Now we have to substitute t equal to 0. When t equal to 0, this complete thing will become 1. It is 1 and this when t equal to 0, it is 0 and here it is completely minus 1 by 2 plus beta. And these thing, they are saying that this limit is equal to 0. What is the value of beta then? Beta equal to 1 by 2. Alpha equal to minus 1, beta equal to 1 by 2. They are asking 8 into alpha plus beta. 8 into alpha is minus 1, beta equal to plus 1 by 2. What it will become? 8 into, here it is minus 1 by 2 plus 1 by 2 plus 1 by 2. Is it true? 1 second. Minus 1 plus 1 by 2. What it will become? Minus 1 by 2. 4, that is minus 4. So the answer is C. So like this you have to solve. You have to find alpha and beta by evaluating the limit in such a way that the limit should exist, and after existing the limit we have to find by using L'Hopital rule we can evaluate the complete limit and equate it to 0, because they are saying that this limit is equal to 0. So the third question is completed. Now fourth question. Fourth question, they are saying that the value of limit extending to 1 x square minus 1 into sine square pi x. Sine square pi x divided by x power 4 minus 2x cube plus 2x minus 1 is equal to what? Option A, pi square by 6. Basically these limit questions are very simple. You have to find which method is suitable, because these questions are simple as well as lengthy also sometimes, but you have to choose a method which makes it simple. So basically this is a question. They are saying that the value of limit extending to 1 x square minus 1 into sine square pi x divided by x power 4 minus 2x cube plus 2x minus 1 is equal to, and whenever you are going to solve a limit question, first you have to check, I already said, what is the limit, that is which indeterminate form is. When extending to 1, this is 0 and here it is 1 minus 2 plus 2 minus 1, it is also 0, that is 0 by 0 form. And again when we check this multiplication here and also sine square pi x, suppose if we think it is a box, when extending to 1, this box is tending to 0. So here directly you can substitute. Here directly you can make an idea, that is when extending to 1, this box is tending to 0. So you can directly make an idea here, that you can here directly substitute the value. 1 second. Basically I am making here limit extending to 1 x square minus 1 into sine pi x divided by pi x whole square into pi square x square divided by x power 4 minus 2x cube plus 2x minus 1. And when extending to 1, this thing is tending to 1, that is limit extending to 1 x square minus 1 into pi square x square divided by x power 4 minus 2x cube plus 2x minus 1. And when extending to 1, it is now 0 by 0 form. What we can do? We can use L'Hopital rule and we can find the answer. When extending to 1, here what will it become? The pi square is constant here, and here it is x power 4 minus x square divided by x power 4 minus 2x cube plus 2x minus 1. It is limit extending to 1. And when limit extending to 1 and using L'Hopital rule, differentiating the numerator and denominator, it will become 4x cube minus 2x divided by 4x cube minus 2x square plus 2. And again check, when it is 1, that is pi square, into when it is 1, what it will become? 4 minus 2 divided by 4 minus 2 plus 2. 1 second. The options are correct only. One second. So here again you can use again L'Hopital rule. Again using L'Hopital rule, what you will get? Limit extending to 1, pi square into 12x square minus 2. Here it is 12x square minus 2. Down, these two things will get cancelled and pi square is constant. So the final answer is pi square. So like this you can do. So the answer is pi square, D. Now fifth. The fifth question which I am going to discuss is very important, because this question is very much repeated in all the ships. All the ships, and in the previous years also it has been repeated. When the value of limit n tending to infinity 6 tan sigma r equal to 1 to n tan inverse 1 divided by r square plus 3r plus 3 is equal to option A 1, option B 2, option C 3, option D 6. So basically this is a question. These type of questions are very much repeated in JEE Mains. By seeing this thing, it is very clear that it is inverse, and these things can be solved very easily. That is sigma r equal to 1 to n. Leave this thing. I am breaking this question into two parts, that is the inverse part and the second part is limit part. First we have to solve the limit, that is inverse part. When r equal to sigma r equal to 1 to n, tan inverse of 1 divided by r square plus 3r plus 3. So we have to make the denominator in such a way that it is the form of 1 plus something into something. Like this you have to make. So for that I am splitting 3 as 2 plus 1. So I am writing the one part here directly. This one part I am writing here down, that is 1 plus r square plus 3r plus 2. The remaining part here 2. Now sigma r equal to 1 to n tan inverse of 1 divided by 1 plus this r square plus 3r plus 2 can be written as r plus 1 into r plus 2. And again this is the second step. We have make like this. Now it is the point you have to make the numerator in terms of these two things. How? Here it is 1. The 1 can be made by using r plus 2 minus r plus 1. So when we solve the above, 1 will be the answer. So we are going to make in a form. So now by observing these things, it is a formula. What is the formula here? Tan inverse of a minus b divided by 1 plus a into b. That is tan inverse of a, that is r plus 2 minus tan inverse of r plus 1. And bahar it is a sigma. So r equal to 1 to n. Now we are solving. Now it is called the rainbow method. That is when r is equal to 1, it will become tan inverse of 3 minus tan inverse of 2. And when it will become tan inverse of that is when we substitute 2, it will become 4 minus it will become 3. And when I substitute n, it will become tan inverse of n, that is n plus 2 minus tan inverse of n plus 1. So now we are going to break it. That is, we are cancelling tan inverse of 3 minus tan inverse of 3, tan inverse of 4, and next term I say cancel होते हैं. Tan inverse of 4 I will cancel like this. What are the remaining terms? These two things. That is tan inverse of n plus 2 minus tan inverse of 2. Now we are again backtracking. That is, we are making this into this form. That is, tan inverse of A minus tan inverse of B formula is tan inverse of A minus B. That is n plus 2 minus 2 divided by 1 plus 2 into n plus 2. What it will become? Tan inverse of n divided by 2n plus, here it is, yes, it is correct only. Here it is 2n, here it is 5. It is correct. Yes, it is correct only. So the final answer for this complete inverse part is tan inverse of n divided by 2n plus 5. Now we are solving the limit part. That is, limit n tending to infinity 6 into tan of this thing, tan inverse of n divided by 2n plus 5. What is tan of tan inverse? It will get cancelled, and finally it will become limit n tending to infinity 6 into only this thing, that is n divided by 2n plus 5. And now limit n tending to infinity, this thing can be solved like this: 6 into n common, 2 plus 5 by n, n will get cancelled, and when limit n tending to infinity, this thing will become 0. Finally, what is left? 1 by 2, 6 into 1 by 2 is left, that it will become 3. So the answer is 3 here. Like this you have to solve. These things are very important because these things are repeating in exam. The tan inverse part, which I solved like this, is very important because these questions are repeated when I am writing in JEE mains examination and JEE advanced examinations, and also my juniors also. It is very important to learn these type of techniques. And now the next question is 7th question, that is limit n extending to 0 alpha into e power x plus beta into e power minus x plus gamma into sin x divided by x into sin square x equal to 2 by 3. Alpha, beta, gamma belongs to R. Then which of the following is not correct? Carefully observe, it is not correct. Options are A, alpha square plus beta square plus gamma square equal to 6. Basically this question want to say we have to solve the question and we have to find alpha, beta, gamma, and we have to verify alpha beta square plus beta gamma square plus gamma alpha square plus 3 equal to 0. Alpha square minus beta square plus gamma square equal to 4. So basically this is a question and these are the 4 options. You have to find alpha plus alpha, beta, gamma, and you have to substitute these values in 4 options and you have to find which is not correct. Which is correct means 3 options will be correct. Maybe A, B, D will be correct, A, B, C will be correct, whatever. So we have to solve alpha, beta, gamma. When we observe these things here and directly by seeing the denominator, we by observing the limit, when extending to 0, that is when limit extending to 0 sin x by x equal to 1, by observing these things, I can directly transform this question into limit extending to 0 alpha into e power x plus beta into e power minus x plus gamma into sin x divided by x into sin square x divided by x square into x square. So these things can be written as whole square here, When extending to 0, this complete thing will become 1, and also this complete thing is 1. So the denominator is x cube here. Completely we can rub here, and suppose I am writing here alpha into e power x plus beta into e power minus x plus gamma into sin x divided by x cube. Up to now we have solved this question. Now what we can do alpha, that is e power x and e power minus x and sin x. These things cannot be removed by normal method. So we have to use the another powerful tool, that is expansion. I already discussed it in the limit section. The expansions are of so many types: sin x, cos x, secant inverse x, tan inverse x, sin inverse x, cos inverse x, e power x, log 1 plus x. So here what are the expansions needed? E power x expansion is needed, e power minus x expansion is needed, sin x expansion is needed. So I am writing the expansions here. What is the expansion of e power x? 1 plus x square, 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial. And what is the expansion of e power minus x? 1 minus x plus x square divided by 2 factorial minus x cube divided by 3 factorial. And what is the expansion of sin x? X minus x cube by 3 factorial. And so on. But the denominator is restricted to x cube. That is the reason why I am writing up to x cube. Now we have to substitute these expansions into here. So basically I am rubbing here this thing to save the space. So when you apply this here, that is this expansion here, it will become alpha into e power x expansion is 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial. Okay. And next plus beta into what is expansion of e power minus x? 1 minus x plus x square divided by 2 factorial minus x cube divided by 3 factorial. And what is expansion of sin x? Gamma into sin x minus x cube by 3 factorial. X minus x cube divided by 3 factorial divided by x cube. I am rubbing this thing. I did not done any rocket science thing here. I basically applied the expansions here and converted this complete question into this thing. That how denominator is converted to x cube I already explained. So I am rubbing here and solving this question again. Up to now we solved like this. Now it is a time to segregate. What are the x cube terms, x square terms? Basically when the limit is going to exist. When numerator and denominator degree equal. Here degree is 3, so we have to make the term here cube term. So I am writing x cube coefficients. What is x cube coefficients here? Alpha divided by 3 factorial. Here it is minus beta divided by 3 factorial. Here it is minus gamma divided by 3 factorial. These things are x cube terms. And what are the x square terms? X square terms, it is alpha divided by 2 factorial and plus beta divided by 2 factorial, and here there is no term, so we can leave it. And what is the x terms here? X terms, it is alpha here it is minus beta, here it is plus gamma. And what are the constant terms here? Constant terms are alpha and here beta. There is no constant term here, so we can write like this, divided by complete x cube. And here it is limit extending to 0. Don't forget the limit extending to 0. How you understand here? Or you understand how I segregate like this? Basically I multiplied alpha to every terms and directly segregate x cube, x square, x and constant terms here. Now limit extending to 0, I already said when limit is going to exist, when here this degree is present and the remaining terms are all 0. So basically these all terms should be 0. That is alpha plus beta divided by 2 factorial should be equal to 0. Alpha minus beta plus gamma, it should be equal to 0. And alpha plus beta equal to 0. So basically these two things refer same thing only. Alpha plus beta equal to 0. These three conditions is important here. And another thing, when these things are 0, so basically these things are all equal to 0. And x cube cancel. What is the thing left? That is alpha minus beta minus gamma divided by 3 factorial is 6, which is equal to 2 by 3. 3 ones, 3 twos. Alpha minus beta minus gamma equal to 4. This is another condition. I am rubbing this thing. Basically, what are the conditions? We got alpha plus beta equal to 0. Alpha minus beta plus gamma equal to 0. Alpha minus beta minus gamma equal to 4. By solving these two things, we will get this one will get cancelled, adding here 2 into alpha minus beta equal to 4, alpha minus beta equal to 2. And by solving these two things, alpha plus beta equal to 0, 2 alpha equal to 2, alpha equal to 1. When alpha equal to 1, beta equal to minus 1. When alpha equal to 1, beta equal to minus 1. By substituting these two things in this equation, what you will get? When alpha equal to 1 and beta equal to minus 1, gamma equal to minus 2. So by solving these questions, we got alpha, beta, gamma. Now it is a time for verification. I am rubbing this entire thing. We got alpha equal to 1, beta equal to minus 1, gamma equal to minus 2. Now let's verify. First option. They are saying that alpha square plus beta square plus gamma square equal to 6. Alpha square is 1 square, beta square is minus 1 square, plus gamma square is minus 2 whole square. Let's check. 1 plus 1 plus 4, that is 6 equal to 6. Yes, this option is correct, but it is not the correct option. This answer is correct, that is this thing is true, but it is not the option because they are asking not correct. And let's check option B. They are saying that alpha beta plus beta gamma plus gamma alpha plus 1 equal to 0. Let's check. Alpha into beta, 1 into minus 1, it is minus 1. Beta into gamma, that is plus 2. Gamma into alpha, it is minus 2 plus 1 equal to 0. They are saying minus 1 plus 1 cancel, 2 minus 2 get cancelled, so 0 equal to 0. So this option is also true. Now let's check the third option. What they are saying? Alpha beta square plus beta gamma square plus gamma alpha square plus 3 equal to 0. They are saying alpha, it is minus 1, beta square it is 1, plus beta is equal to minus 1, gamma square is equal to 4, gamma is minus 2, and alpha square is 1 plus 3. They are saying that it is equal to 0. Here it is like this. So it is basically 4 minus 4 plus 2. So minus 2, which is not equal to 0, but they are saying it is equal to 0. So this option is false. So this option is correct. That is, which is not correct, the option is C only here. So because C is not correct here. So like this you have to solve this question. Now 8th question. Now let's solve 8th question. Limit x tending to 0, 48 divided by x power 4, 48 divided by x power 4, t cube divided by t power 6 plus 1 dt, integration 0 x here, is equal to. Up to now we are not solved any integer type question. Now it is a time to solve the integer type question. They are saying that limit extending to 0, 48 divided by x power 4 integration 0 to x t cube divided by t power 6 plus 1 dt. So you are thinking that why here I am discussing limits, why we got integration. Basically this question we got in the JEE Mains 2023 January attempt, and they asked mixed question, that is integration as well as the limit. Basically here the complete concept is limit only. You will definitely love this question. So when we see this question, it will completely transform into limit extending to 0, 48 into integration 0 to x t cube divided by t power 6 plus 1 dt divided by x power 4. Basically this is a question. Write neatly because you can understand. When extending to 0, observe the pattern. When extending to 0, it is integration from 0 to 0, which is 0, because limit a, that is integration a to a, it is 0 only now. When we supply the limits, it will become 0. So the numerator is 0 and the denominator is 0 power 4, it is 0. It is L'Hopital. that is 0 by 0. What we can, how much we can solve this question? How we can solve this question? We can solve this question by using L'Hopital rule. What L'Hopital rule says? You can directly differentiate the numerator and denominator separately. So limit extended to 0, 48 into what is the differentiation of integration? Here it is the Leibniz theorem. What Leibniz theorem says? Integration a to b f of x d by differentiation d by dx. What is the differentiation here? That is f of b into b dash minus f of a into a dash. Like this you have to solve. Here what we will get? 48 into x cube divided by x power 6 plus 1 into what is the differentiation of x? It is 1. And it is 0, we get 0. No need to solve this part. This part we got solved. This part no need because it is constant only. Divided by 4x cube. 4x cube. And now when you observe this question, 48x cube divided by 4x cube into x power 6 plus 1. X cube term is cancelled. 4 ones, 4 12s. And when x is tending to 0, it will become 12 divided by x power 6 plus 1. When x is 0, 0 power 6 is 0, we got 12 by 1, which is 12. So this complete answer is 12 here. Like this you have to solve. This is integer type. 8th question got completed. Now 9th question. Ninth question, let x equal to 2 be a root of the equation x square plus px plus q equal to 0 and f of x equal to 1 minus cos x square minus 4px plus q square plus 8q plus 16. The question can be lengthy, but don't worry. It can be solved so easy when you think logically. Then limit extending to 2p plus 2 1 0 minus 1. So basically this is a question, complete question. Let x equal to 2 be the root of the equation x square plus px plus q equal to 0. Basically they are saying that the 2 is the root of this equation and f of x is defined by when x is not equal to 2p, this function is valid. When x equal to 2p, the answer is 0. They are asking limit extending to 2p plus what is the value of f of x, and here this term represents greatest integer. So basically they are asking limit extending to 2p plus what is the greatest integer of f of x. Options are 2, 1, 0, minus 1. Now let's solve step by step. When x equal to 2, this is the root of this equation. So we can substitute the value. X square plus px plus q equal to 0. When x equal to 2, this is a root. It will become 4 plus 2p plus q equal to 0. It will become q equal to minus of 4 plus 2p. Like this you can take. And now when you observe this thing, this big term, basically when you solve so many questions, you don't see this term also. You can directly write this term as x minus 2p whole square. Why? Because I solved many questions. That is the reason why I am writing. So if you also solve so many questions, you can clearly see that what is the denominator x minus 2p whole power 4. In limits you understand one thing, that is when x tending to 0, 1 minus cos x divided by x square is equal to 1 by 2. Here x, it is x square here. Here it is power 4, it is square only now. This complete term, it is present here. And it is in the square form. So square and square. So this term can be written as x minus 2p whole square. But I am saying directly, you can assume x square minus 4px plus q square plus 8q plus 16. These things you can solve. When you solve these things, you can get an idea. Basically, these complete one second. Here it is also q terms also present, na? No, you cannot directly write because you have to use here q. Q is minus of 4 plus 2q. You have to use this thing. When you use this thing, you can write. Substituting this q equal to minus 4p here. Q square plus 8q plus 16. When you substitute q value here, this complete term will become like this. I already said to you. Means here the immediate step is ignored. That is, what is the immediate step? We have to substitute the q value here and convert this complete term as x minus 2p whole square. But what I decided, here it is in the form of 1 minus cos x divided by x square. So this complete numerator part I can transform into 1 minus cos of x minus 2p whole square divided by x minus 2p whole power 4. Why I doing directly? Because after substituting this q equal to minus of 4 plus 2p in this form, it is converted into x minus 2p whole square. I know that. That is the reason why I transform. Now, when it is like that, and also the limit x tending to 2p. And here they are asking this thing, limit extending to 2p plus. So I can make it limit extending to 2p plus and also fractional part of this thing. So basically this is a question they are asking. Limit extending to 2p plus 1 minus cos of x minus 2p square divided by x minus 2p whole power 4. What is the value? I already said when extending to 2p or 2p plus or 2p minus, what is the answer for this limit? This answer is 1 by 2. That is limit extending to 2p plus, it is 1 by 2. And what is the greatest integer of 1 by 2? It is 0. So limit extending to 2p plus, it is 0. It is 0 here. And what is the limit extending to 2p plus 0? It is 0 only. So the answer here is 0. Like this you have to solve. The 9th question completed. Tenth question. Tenth question, it is limit. Don't afraid by saying this question. 1 plus 2 minus 3 plus 4 plus 5 minus 6 and so on up to 3n minus 2 plus 3n minus 1 minus 3n. At the starting times when I am solving the questions in limits, by seeing these big terms only, I move to another question. Because these things make you confused and make you afraid. But these questions are simple than anything. But you have to maintain the patience and solve these questions very neatly. The examiner tries to afraid you, but you should not afraid. So this is a question, 10th, that is limit n tending to infinity. Again we got n tending to infinity limits. N tending to infinity 1 plus 2 minus 3 plus 4 plus 3 5 minus 6. When you observe these things, it is a bundle. When you observe these things, it is a bundle. 1 plus 2 minus 3, 4 plus 5 minus 6, 3n minus 2 plus 3n minus 1 minus 3n. So the numerator part completely I can transform as a sigma part. So limit n tending to infinity sigma n equal to 1 to n. You can take r equal to 1 to n. I can transform this as 3r minus 2 plus 3r minus 1 minus 3r divided by root of 2. Don't confuse why I taken r equal to 1, because when r equal to 1 and substituting to up to n, you will get this term only now. When suppose if we take n as here, when we substitute n, it will become 3n minus 2. Yes, 3n minus 1. Yes, minus 3n. Yes, it is correct. So that is the reason why I am taking r, again another term, to differentiate from the nth term. And again here 2n power 4, 4n plus 3 minus root of n power 4 plus 5n plus 4. Sorry guys, here n power 4 plus 5n plus 4, and when you see the numerator part, 3r will get cancelled, and here 3r minus 3, we can take 3 as common in the numerator, we can get 3 into r minus 1, and here it is sigma n limit n tending to infinity, and in the denominator it is 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. Now, don't confuse here. See, r equal to 1 to n, 3 into r minus 1 here. And when we substitute 1 by 1 term, that is opening sigma, what you will get? You will get 0 plus 3 plus 6 plus 9 up to n terms divided by this thing, root of 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. So here in the numerator part, it is the summation of n terms. What is the formula of summation of n terms? It is n by 2 into 2a plus n minus 1 into d. I am applying this formula here. I am rubbing the upper part so I can save the space. So by applying this formula, that is n by 2, how many terms it will be? N terms only. So the formula is n by 2 only into what is the value of a? That is first term, it is 0. So this term will get cancelled. And what is the value of d here? D is 3 divided by same thing, root of 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. This thing, I am rubbing this thing also. Now, I am writing neatly 3n by 2 into n minus 1 limit n tending to infinity. Don't forget the limit. 2n power 4 plus 4n plus 3 minus root of n power 4 plus 5n plus 4. Now I am taking common n square in the numerator. It will become 3 by 2 into 1 minus 1 by n. Like this it will become. Is it true? Yes. And in the denominator I am taking n power 4 common. So by taking the root, it will become root of 2 plus 4 by n cube plus 3 by n power 4 minus root of 1 plus 5 by n cube plus 4 by n power 4. N square will get cancelled, and when is n tending to infinity, this thing will 0, this thing will be 0, this thing will be 0. And here it is 3 by 2 here, 3 by 2. In the denominator it is root 2 minus 1 here. In the denominator you can observe, here it is 3 by 2, here it is root 2, and here it is minus 1. So the complete solution is this only, 3 by 2 into root 2 minus 1. But every JEE aspirant will confuse now, because answer we got 3 by 2 denominator into root 2 minus 1, but there is no option here. The minus option is only not present here. So now what you have to do, you have to rationalize this thing with root 2 plus 1. Now you will get 3 root 2 plus 1 here divided by 2 into root 2 minus 1 into root 2 plus 1. What it will become? Root 2 whole square minus 1 square. It will basically, this thing will become 1. So here 3 into root 2 plus 1 here divided by 2. The option is 3 by 2 root 2 plus 1. Option is C. Like this you have to solve. Tenth question got completed. Now 11th question. If the if the function f of x equal to, again we are defining the function log of 1 minus x plus x square plus log 1 plus x square. Every question will give a new logic to you, new logic and new tricks to solve. You have to find that thing. You can skip the writing part and you can save the time, because now I am writing in the board, so it will take time to write the question. So you can save your time by skipping 5-10 seconds, so it will be beneficial for you. 1 minus 1 is 0. Let's discuss this question. They are saying that if this function f of x log of 1 minus x plus x square plus log of 1 plus x square divided by secant x minus cos x, this thing is defined when x belongs to minus pi by 2 comma pi by 2, when we include 0, that is exclude 0, and when x is equal to 0, the value is k. They are asking that is, and this function is continuous at x equal to 0. Then what is value of k? When we say the value is continuous, that is the function is continuous, when the LHL equal to RHL equal to function of value of the function, these thing we can say the continuous. So the function should be limit extending to 0, LHL should be equal to limit 0 plus RHL equal to function value at 0. This thing we can say the function is continuous. So now I am solving limit extending to 0, this part, complete part. But before writing and to save the space, I am saying here only, that is here 1 minus x plus x square, and here it is 1 plus x square. Now I got an idea, and also there are log terms. What is the value of log m into log m plus log n? It is log mn. So I can easily make them as mn, that is multiplication. So that is log of 1 minus x plus x square into 1 plus x square. And again to save the space, I am converting these things. What is the value of 1 minus x plus x square into 1 plus x square? It is completely equal to x power 4 plus x square plus 1. So limit extending to 0, log of x power 4 plus x square plus 1 divided by secant x minus cos x. Secant x can be written as 1 by cos x, and cos x is a LCM, and it is going to in the upper part, and down it is 1 minus cos square, it is sin square x. And again, by seeing that limit extending to 0, again I got an idea. This thing can be transferred into x square into x square, and this term is equal to 1. Now we have to solve this thing, this complete thing. How to solve this? Now again I got an idea, that is this complete, it is 1. Now by seeing this one here, I got an idea to use a relation, that is when limit extending to 0, log of 1 plus x divided by x is equal to 1. So by using that identity, I can transfer this question as 1 plus x square plus x power 4 divided by x square plus x power 4 into x square plus x power 4 into cos x divided by x square. And this complete thing is equal to 1 here, and taking x square common in the numerator, I will get like this. X square will get cancelled, and when we substitute x equal to 0 here, I will got 1. Is it clear to you? When extending to 0, 1 plus 0 into cos 0, it is 1. 1 into 1, 1. 1 divided by 1, 1. So the answer is here. Like this you have to solve. limit extending to 1 sine of 3x square minus 4x plus 1 minus x square plus 1 divided by 2x cube minus 7x square plus ax plus b. This limit is equal to 2 minus 2 they are saying. Then value of a minus b is, and again now the integer question, integer value. They are asking when limit is equal extending to 1, this thing is equal to minus 2. What is the value of a and b? Here it is a, here it is b. Now we have to solve. First I will check which limit is this. Extending to 1, this it is 3 minus 4 plus 1, it is 0, sin 0 it is 0. Here it is, when we substitute here minus 1 plus 1 it is 0. So the numerator is 0. Denominator, when we substitute 2 minus 7 it is minus 5. That is the limit should exist. Here we are checking which indeterminate form is. No need to check that because they already said it is existing, that is minus 2. So you can directly substitute this one and you can check directly. The numerator part is 0 here and denominator part is 2 minus 7 plus a plus b. It should be equal to minus 2. That is, it should be equal to minus 2, but when the limit is existing. But here when we check, it will become minus a plus b like this, but it is not equal to 0. So we have to make a plus b equal to 5 to make this term as 0. So we got a relation a plus b equal to 5, but the trick part is they are asking a minus b. So now you have to solve this thing. How we can solve? We can directly use a L'Hopital rule. That is, limit extending to 1 cos of 3x square minus 4x plus 1 into 6x minus 4 minus 2x divided by 6x square minus 14x plus a. Again I am going to check by applying the 1. When I apply 1, it is cos 0. It is cos 0, it is 1 into, when I apply 1 here, it will become 2 minus, here it is 2 divided by 6 minus 14 plus a. Here it is 0 divided by minus a plus 8 plus a. But again it should be what exist? It should be exist. So this term it should be equal to 0. So minus 8 plus a equal to 0, a equal to 8. And when a equal to 8, what is the value of b? It is 8 plus b equal to 5 and b equal to 3. B equal to minus 3. Now they are asking a minus b. What is the value of a? 8. What is the value of b? B is minus 3. 8 plus 3, that is 11. So the answer is 11 here. Like this you have to solve. Now we come to an end and we are going to discuss the last question. Last question, that is, let a be an integer. Let a be an integer such that limit extending to 7, 18 minus step of 1 minus x divided by x minus 3a exist. Then a is equal to option A, option B, option C, option D. Minus 2, 6, minus 6, minus 7. So here, now it is a time to solve the actual limit question, because it is very important to solve this type of question, because these questions are really confusing to the students. So they are asking limit extending to 7, 18 minus step of 1 minus x divided by 3x minus 3a. This is greatest integer part and they are saying that it should exist. And how we can solve? The greatest integer parts are solved by using the term, that is h, and by using limit h tending to 0, I can write, that is I can take LHL RHL. LHL part, RHL part. When h tending to 0, 18 minus, that is LHL means, what is the meaning of LHL? That is, it is extending to 7, extending to 7 minus. So extending to 7 minus, I can write as 7 minus h. Extending to 7 minus h, I can write. So when extending to 7 minus and h minus 7, I can write limit h tending to 0, 18 minus of 1 minus 7 plus h divided by 7 minus h minus 3a. I can write like this. And RHL part, that is limit h tending to 0, 18 minus 7 plus, that is RHL part, 7 plus, we can write 7 plus h, 1 minus 7 plus h divided by 7 plus h minus 3a. And when you observe these things clearly, here 7 is integer, a, they said a is an integer, so basically these things can be removed here. That is limit h tending to 0, 18 minus 6 plus h here divided by, here we can write 7 minus 3a part plus of fractional part of minus h. Like this you can write here. Limit h tending to 0, basically there is a property. What is the step of expression? It is step expression, where n is an integer. This property holds in the greatest integer part. When and limit h tending to 0, here it is 18 minus of 1 minus h divided by, here it is 7 minus 3a plus fractional part of h. And now when you observe carefully here, when h is tending to 0, what it will become? It is 0. What is the fractional part, that is greatest integer part of minus 6? It is minus 6 only. So the upper part is 24. 18 plus 6, that is 24. And the denominator part is, when h is tending to 0, take number line. When h is tending to 0, what is the value of greatest integer? It is minus 1. So here it is minus 1. And where by when you substitute h tending to 0 here, it is 0. Here it is minus 6 here. Here it is minus 6. One second. 7 minus h, because 7 minus, yes, it is 7 minus minus 7 plus h, it is correct only. Here it is 7 plus h, it is also correct. But when h is tending to 0, 1 minus 7 is minus 6. into step of minus 6 is that is plus 6 only. Yes, it is correct. But what is the value here? 1 minus 7 and minus h. Yes, it is correct only. Okay, 18 into that is here, it is also 24, and here 7 minus 3a, and h is tending to 0, and when it is plus h, when h is tending to 0, it is 0 only. So the final answer is 24 divided by 7 minus 3a. Here it is 24 divided by 7 minus 3a minus 1. Now we have to equate these things, LHL and RHL we have to equate, because this limit is existing. When the limit is exist, when these two things will be equal, 7 minus 3a minus 1, basically it is 6 minus 3a. This thing equal to 24 divided by 7 minus 3a. When you solve this thing, 1 by 6 minus 3a equal to 1 by 7 minus 3a. 7 minus 3a equal to 6 minus 3a. Basically there is a doubt for me, because we have to recheck here, because these things cannot be equal, that is 24 same things we cannot get here. We have done some mistake here. Step of 1 minus x. For LHL part it is LHL means 7 minus h. Yes. And for RHL part it is 1 minus 7 plus h. 1 minus 7 plus h minus 6 plus h. Basically there is a confusion here. 1 second. Seven minus 3, yes, it is correct. Yes, we have done some mistake here. I can clarify this. Let's do one more time. LHL part, RHL part. What I said, limit h tending to 0, h tending to 0, 18 minus 1 minus 7 minus h here, yes, divided by x minus 3a, that is x is 7 minus h here, yes. Now RHL part, limit h tending to 0, here it is 0 minus, here, that is we can take 0, 18 minus 1 minus 7 plus h divided by 7 plus h minus 3a. The numerator, the denominator parts, it's clear. Here it is 7 minus 3a, it is clear. Here minus 1. These parts can be easily right, because I already explained in the previous thing. Here it is 7 minus 3a only, just. This thing can be written as 6 minus 3a. Yes, this thing is clear to us, but there is a problem in the numerators part. So now I am doing this 18 minus of, here it is minus 6 plus h. And here you can observe this minus 6 is an integer. So I can take, I can write as minus of minus 6 h here. I can write like this. Here it is 0. When h is tending to 0, this thing is 24. 24 divided by 6 minus 3, it is clear. And here when we will do like this, 18 minus of minus 6 plus h here. Minus 6 plus h, but here it is fractional part. Here it is 18 plus 6 minus 1 here. Yes, because it is minus of, that is here h is tending to 0 and it is minus. So it will become minus. Here it is 7 minus 3 here. So the numerator part is 23 here. So now we have to equate 24 divided by 6 minus 3a to 23 divided by 7 minus 3a. So 7 4 is 28, 168 minus 12 equal to 23 into 6, 18, 138. 138 minus 23 into 3, it is 969. Now when you solve these things, what you will get? You will get 3a equal to 168 minus 138. You will get 0, 30. Is this correct? 70, 71, 72. 24 3s, it is 72 only. 14, 3 to 6, 72, 8 is correct. 22 3s are, yes, it is also correct. But how we are getting like this? 23 into 6, 6 3 is 18, 6 2 is 12, 13, yes, correct. 24 into 7, 7 4 is 28, 7 2 is 14, 15, 16, yes, it is also correct. But we are getting a as 10, but a cannot be 10. So there is a problem here. So basically here the numerator part is different, but the answer we can get here. Basically the answer is minus 6. You have to check the LHL and RHL part in the upward parts. How we can solve this thing? Basically there is a mistake here. So that's it, guys. We are getting -6. Check this once whether it is correct or not. -6 we have to get, and check this process also. If there is any confusion, comment in the below. Again explain this question in the next session, that is next continuity and differentiation session. If you have any doubt, comment in the comment section. I will take the doubt, and I will recheck, because this thing is really confusing, because this greatest integer we have to solve very clearly. So that's it, guys. If you like this video, subscribe to this channel and also join the Telegram group. It is very important, where I can update you everything about the JEE Mains registration, and also everything related to JEE Mains and advanced. So that's it, guys. Thank you.